Chapter 16 Light plays an important role in our life. No activity is possible without light. Light is the form of energy that provides sensation of vision. Some common phenomenon associated with lights are image formation by mirrors, the twinkling of stars, the beautiful colors of rainbow, bending of light by a medium, and so on. Through it we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night we see the moon and the stars. You are able to see the words and sentences printed on this page. How is seeing made possible? What makes things visible? Do you know that how we see various objects? We are able to see because light from an object can move through space and reach our eyes. You may say that I see the objects. But, can you see an object in the dark? It means that eyes alone cannot see any object. It is only when light from an object enters our eyes that we see the object. The light may have been emitted by the object, or may have been reflected by it. You have studied in class 7 that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? Let us find out. Law of reflection. Reflection is the bouncing back of light rays on striking the surface. After striking the mirror, the ray of light is reflected in another direction. The light ray, which strikes any surface, is called the incident ray. The ray that comes back from the surface after reflection is known as the reflected ray. Draw lines showing the position of the plane mirror, the incident ray, and the reflected ray on the paper with the help of your friends. Remove the mirror and the comb. Draw a line making an angle of 90 degrees to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as the normal to the reflecting surface at that point. Figure 16.2. The angle between the normal and incident ray is called the angle of incidence, pi. The angle between the normal and the angle of reflection, PR. Fig. 16.3. Measure the angle of incidence and the angle of reflection. Repeat the activity several times by changing the angle of incidence. Do you observe any relation between the angle of incidence and the angle of reflection? Are they approximately equal? If the experiment is carried out carefully, the law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection. Whole sheet of paper is spread on the table represents one plane. In this plane, the incidence ray, the normal at the point of incidence, and reflected ray are present. When you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. What does it indicate? It indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. This is another law of reflection. My friends perform the above activities outside the classroom with the sun as the source of light instead of a torch. You, too, can use the sun as the source of light. You remember that in class 7, you had studied some features of the image of an object formed by a plane mirror. Let us ask him to recall those features. I. Was the image erect or upside down? 2. Was it of the same size as the object? 3. Did the image appear at the same distance behind the mirror as the object was in front of it? 4. Could it be obtained on a screen? Let us understand a little more about the formation of an image by a plane mirror in the following way. You can remember that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. Regular and diffused reflection. When parallel rays of light fall upon an irregular surface, they are reflected back into all the directions. For example, the reflection of rays of light through a wall or cardboard. It is caused by the irregularities in the reflecting surface. On the other hand, Reflection from a smooth surface like that of a mirror is called regular reflection, figure 16.8. Images are formed reflection. Reflected light can be reflected again. Do you remember that when you go to a hairdresser, he says to sit in front of a mirror. After completing cut your hair, he holds a mirror behind you to show you how the hair has been cut. Can you imagine how you could see the hair at the back of your head? Do you know about the periscopes? The periscope makes use of two plane mirrors. Can you explain how reflection from the two mirrors enables you to see objects which are not visible directly? Periscopes are used in submarines, tanks and also by soldiers in bunkers to see things outside. Multiple images. You know very well that a plane mirror forms only a single image of an object. What happens if two plane mirrors are used in combination? Let us see. Can you now explain how you can see the back of your head at the hairdresser's shop? This idea of number of images formed by mirrors placed at an angle to one another is used in a kaleidoscope to make numerous beautiful patterns. Kaleidoscope is a device that works on the phenomenon of multiples reflection with the leap of multiple mirrors. You can also make a kaleidoscope yourself. Your kaleidoscope is ready. When you peep through the hole, you will be able to see a variety of patterns in the tube. When the light falls upon these objects in the kaleidoscope, multiple reflection of these objects are created in the three mirrors. This results in the formation of beautiful and colored patterns. Since the reflection of light is not always the same, the observer never sees a similar pattern in the kaleidoscope. Designers of wallpapers and fabrics and artists often use kaleidoscopes to get ideas for new patterns. To make your toy attractive, you can wrap the kaleidoscope in a colored paper. Sunlight, white or colored. The sun is the biggest source of light on the earth. The sunlight is white in color, however, this white light often disperses into several colors. It consists of 7 colors. Here is another activity, activity 16.7, showing that sunlight consists of several colors. What is inside our eyes? Eyes are sensory organs that allows us to see things present in the environment. It is therefore important to understand its structure and working. The eye has a roughly spherical structure. The outer coat of the eye is white. It is tough so that it can protect the interior of the eye from accidents. Its transparent front part is called cornea, figure 16.14. Behind the cornea, there is a dark-colored muscular structure present in the center of the cornea called iris. The iris consists of a small opening called pupil through which the light enters into the eye. The iris is that part of eye which gives it its distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. Let us see how. Lens is like a sphere of liquid present inside the eye. The eye lens is located behind the pupil, which helps in the formation of an image in the eye. The lens focuses light on the back of the eye, on a layer called retina, figure 16.14. The retina contains several nerve cells. Sensations felt by the nerve cells are then transmitted to the brain through the optic nerve. There are 2 kinds of cells: eye cones, which are sensitive to bright light, and 2 rods, which are sensitive to dim light. Cones sense color. At the junction of the optic nerve and the retina, there are no sensory cells, so no vision is possible at that spot. This is called the blind spot. Its existence can be demonstrated as follows. The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. So, if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object as. The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at the rate of 24 pictures per second, faster than 16 per second. So, we see a moving picture. Nature has provided eyes with eyelids to prevent any object from entering the eye. Eyelids also shut out light when not required. Eye is such a wonderful instrument that it, normal, can clearly see distant objects as well as objects nearby. The minimum distance at which the eye can see objects distinctly varies with age. The most comfortable distance at which one can read with a normal eye is about 25 centimeters. Some persons can see objects close to them clearly but cannot see distant objects so clearly. On the other hand, some persons cannot see objects nearby clearly but they can see distant objects quite well. With suitable corrective lenses, these defects of the eye can be corrected. Sometimes, particularly in old age, eyesight becomes foggy. It is due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. There is a loss of vision, sometimes extremely severe. It is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Modern technology has made this procedure simpler and safer. Care of the eyes. Eye is one of our most important sense organs which give us the sense of vision. We see objects only when light coming from objects enters our eyes. Eyes are a very sensitive organ. So it is necessary to take proper care of your eyes. If you feel any problem in your eyes, you should go to an eye specialist. If advised, use suitable spectacles. Too little or too much light is bad for eyes. Insufficient light causes eye strain and headaches. Too much light, like that of the sun, a powerful lamp or a laser torch can injure the retina. Do not look at the sun or a powerful light directly. Never rub your eyes. If particles of dust go into your eyes, wash your eyes with clean water. If there is no improvement, go to a doctor. Always read at the normal distance for vision. Do not read by bringing the book too close to your eyes or keeping it too far. You learnt about balanced diet in class Virgin Islands. If food is deficient in some components, eyes may also suffer. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is night blindness. One should, therefore, include in the diet components which have vitamin A. Raw carrots, broccoli and green vegetables, such as spinach, and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter and fruits such as papaya and mango are also rich in vitamin A. Visually challenged persons can read and write. Some people including children face with disability of vision. This disability of vision can be partial or complete. Such persons are called visually challenged persons. Some person may lose their eyesight because of a disease or an injury. Such person usually show a marked development of other senses. I like the sense of hearing and sense of touch. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. Visually challenged people learn the Braille system by beginning with letters, then special characters and letter combinations. Methods depend upon recognition by touching. Each character has to be memorized. Braille texts can be produced by hand or by machine. Typewriter-like devices and printing machines have been developed.